At 6:24 in the evening, a Boeing 747 is climbing away from Tokyo. There are 524 people on board. Families, children, business travelers, people heading home for one of Japan's most important family holidays. The flight should last less than 1 hour. Tokyo to Osaka, a short domestic trip on one of the busiest air routes in the world. The crew is experienced. The aircraft is massive. The weather is not the problem. The engines are running normally. Then, 12 minutes after takeoff, a sound like an explosion tears through the rear of the airplane. The cabin loses pressure, the vertical tail breaks away, and in a single moment, every hydraulic system on the aircraft is gone. The pilots move the controls. The airplane does not respond. A Boeing 747, one of the largest passenger aircraft ever built, is now flying with almost no conventional control. No working rudder, no normal elevators, no normal ailerons, no hydraulic power. Only the engines still answer. For the next 32 minutes, 3 men in the cockpit will try to do the impossible. They will try to fly a crippled 747 using engine thrust alone. They will fight the aircraft as it climbs, dives, rolls, and hunts through the sky. They will be offered airports. They will try to turn back. They will beg the airplane to respond. And in the cabin, passengers will begin writing goodbye notes to their families. This is the story of Japan Airlines Flight 123, the deadliest single aircraft accident in aviation history. A disaster that began not in the sky that evening, but 7 years earlier, with a repair that should never have been done the way it was. Chapter 1. The Holiday Flight. August 12, 1985, was not an ordinary travel day in Japan. It was the beginning of the Obon holiday period, a time when millions of people travel to return to their hometowns, visit relatives, and honor family ancestors. Airports were crowded, domestic flights were full, families wanted to get home. At Tokyo's Haneda Airport, Japan Airlines Flight 123 was scheduled to operate a short domestic service from Tokyo to Osaka. The aircraft was a Boeing 747 SR-46. The SR stood for short range. This was a special version of the 747 designed for Japan's high-density domestic routes where airlines needed to carry hundreds of passengers many times a day between major cities. The aircraft, registered JA8119, had been delivered to Japan Airlines in 1974. By the day of the accident, it had flown more than 25,000 hours and completed more than 18,000 takeoff and landing cycles. That number matters. A short-range 747 does not necessarily fly longer flights than other 747s, but it cycles more often. More takeoffs, more landings, more pressurization cycles, more repeated stress on the aircraft structure. On this evening, the aircraft had already completed another domestic flight, arriving back in Tokyo from Sapporo. It was refueled and prepared for the next leg to Osaka, the cabin filled with 509 passengers. 12 flight attendants prepared the cabin. In total, 524 people were on board. Among the passengers was Kyu Sakamoto, one of Japan's most famous singers, known internationally for the song Sukiyaki. But most of the people on board were ordinary travelers. Parents, children, workers, students, families heading into the holiday. For them, Flight 123 was not supposed to be a story. It was transportation. A short flight home. Chapter 2. The Crew. In command was Captain Masami Takahama. He was 49 years old and had been with Japan Airlines for nearly 19 years. He had flown the YS-11, the Boeing 727, and the Douglas DC-8 before becoming a Boeing 747 captain in 1975. He had more than 12,000 flight hours, including nearly 5,000 hours on the 747. The first officer was Yutaka Sasaki. He was 39 years old, with almost 4,000 hours of total flight time, more than 2,600 of them on the Boeing 747. The flight engineer was Hiroshi Fukuda. He was 46 years old and had worked for the airline for more than 28 years. He had almost 10,000 flight hours, including more than 3,800 on the Boeing 747. This was not a weak crew. This was not an inexperienced crew, and that is one of the reasons this story is so haunting. The pilots who were about to face the worst emergency imaginable were trained, experienced, and professional. But Flight 123 was about to suffer a failure that no simulator session could truly prepare them for. Chapter 3. Takeoff from Haneda. At 6:04 p.m., Flight 123 began taxiing toward runway 15L at Haneda Airport. The aircraft was scheduled to arrive in Osaka at 7:06 p.m., less than 1 hour in the air. The atmosphere on board was normal. Passengers settled into their seats. Cabin crew moved through the aisles. The aircraft lined up for departure. At 6:12 p.m., the Boeing 747 began its takeoff roll. The 4 Pratt & Whitney engines pushed the aircraft down the runway. The 747 lifted off from Tokyo and climbed toward the west. For the first minutes of the flight, everything appeared normal. The aircraft climbed through the evening sky. The crew followed routine procedures. The passengers looked forward to Osaka. At about 6:24 p.m., Flight 123 reached flight level 240, approximately 24,000 feet. Then everything changed. Chapter 4. The Explosion. At 6:24:34 p.m., a loud bang was recorded. The sound came from the rear of the aircraft. In the cockpit, warnings began immediately. The cabin had lost pressure. To the passengers, it would have felt sudden and terrifying. A blast, a pressure drop, oxygen masks, confusion, fear. But what had happened was even worse than decompression. At the rear of the aircraft, the aft pressure bulkhead had failed. The aft pressure bulkhead is a structural wall at the back of the pressurized cabin. In simple terms, it separates the pressurized passenger cabin from the unpressurized tail section. Every pressurized flight loads that bulkhead. The cabin is kept at a pressure humans can tolerate. Outside the aircraft, at altitude, the air pressure is much lower. So the bulkhead must hold back that pressure difference. On Flight 123, it suddenly ruptured. Pressurized air rushed into the tail section. That blast of air damaged the aircraft's tail structure. The vertical stabilizer, the large tail fin that gives the airplane directional stability, separated from the aircraft. And as the tail structure was destroyed, the hydraulic lines running through that area were severed. All 4 hydraulic systems were lost. This is the key to the disaster. A Boeing 747 is controlled by hydraulics. The pilots move the yoke and rudder pedals. Those inputs command hydraulic actuators. The actuators move the control surfaces, elevators, ailerons, rudder, spoilers. Without hydraulic pressure, the flight controls no longer behave normally. Flight 123 had lost the vertical stabilizer and the hydraulic power needed to control the aircraft. In a matter of seconds, a fully loaded Boeing 747 had become almost unflyable. Chapter 5. The First Moments of Confusion. In the cockpit, the crew did not yet know what had actually happened. They heard the bang, they saw the warnings, they felt the aircraft's abnormal behavior. Captain Takahama ordered the transponder set to emergency code 7700. He asked about the landing gear. At first, the crew tried to identify the failure. Was it a door? Was it the landing gear? Was it a pressurization problem? Was it a hydraulic problem? The flight engineer began reporting hydraulic pressure problems. The captain requested an immediate return to Haneda. Tokyo Control responded and began offering vectors. The crew wanted to descend and turn back, but when they tried to control the airplane, it did not respond properly. The first officer turned the control wheel. The aircraft barely obeyed. The captain called for a right turn. The crew tried, but the 747 did not behave like a normal aircraft anymore. Soon the truth became clear in the cockpit. Hydraulic pressure had fallen across the aircraft. All hydraulic systems were gone. The captain asked, in effect, whether all hydraulics had failed. The answer was yes. That moment changed everything. They were no longer handling a decompression. They were no longer handling a single system failure. They were inside one of the most severe control emergencies ever faced by an airliner crew. Chapter 6. A giant airplane without control. To understand what the crew was fighting, imagine trying to drive a car at highway speed after the steering wheel, brakes, and suspension have stopped responding. But the car is in the sky, and it weighs hundreds of tons, and there are 524 people inside. The engines still worked. That was the crew's one remaining tool. By changing thrust on the left and right engines, the pilots could influence the airplane's motion. More thrust on one side could help yaw the aircraft. Changing total thrust could affect pitch. Increasing thrust could raise the nose. Reducing thrust could lower it. But this is not the same as flying. It is slow. It is imprecise. It produces delayed reactions, and on a damaged aircraft without a vertical tail, the response can be unpredictable. Flight 123 began to enter a motion known as phugoid oscillation. The aircraft would climb, lose speed, pitch down, gain speed, descend, then pitch up again. At the same time, it rolled and yawed from side to side. The crew was not simply trying to turn back. They were trying to keep the airplane from entering a completely unrecoverable attitude. Every input took time. Every correction risked making the next swing worse. The airplane was not flying a path. It was wandering through the sky. Chapter 7. The Cabin. While the cockpit fought for control, the cabin crew began preparing the passengers. Oxygen masks deployed. Announcements were made. Passengers were told to fasten their seatbelts. The situation must have been terrifying. A loud explosion, a decompression, an aircraft that was now climbing and descending unpredictably. Cabin crew trying to maintain order. Passengers looking at each other, trying to understand if they were going to survive. In the rear of the aircraft, some passengers would later prove to have been seated in the only area where survival was possible. But no one knew that yet. Inside the cabin, time stretched. The airplane was still flying. That fact may have created hope. If the airplane is still in the air, maybe the pilots can land it. And the pilots were trying. They were doing everything humanly possible. But the aircraft had suffered structural damage beyond what any normal emergency procedure could solve. Chapter 8. Choosing where to go. Tokyo Control offered options. The crew discussed returning to Haneda. They were also offered Nagoya. Yokota Air Base was prepared to accept them. But the issue was not simply choosing an airport. The issue was whether the crew could point the aircraft toward any airport at all. A controllable aircraft with a problem can divert. An uncontrollable aircraft can only be influenced. There is a difference. Flight 123 moved over the Izu Peninsula and Suruga Bay. The pilots tried to turn. They tried to descend. They tried to keep the aircraft away from terrain. At times, it seemed as if they were slowly regaining some ability to direct the airplane using engine thrust. The aircraft began moving in a direction that could have been favorable for a return toward Haneda. But nothing was stable. The airplane continued to oscillate. The crew had to fight the pitch, then the roll, then the speed, then the altitude. They could not simply program an approach. They could not select a heading and fly it. They were in a continuous battle with physics. Chapter 9. Put your heart into it. One of the most haunting moments in the cockpit recording comes when Captain Takahama says words that have been remembered ever since. Put your heart into it. He was speaking to his crew as they fought with the controls. That sentence says everything about the situation. There was no checklist that could give them the airplane back. No button could restore the vertical stabilizer. No pump could rebuild the severed hydraulic systems. No standard procedure could turn a crippled 747 into a controllable aircraft. All that remained was effort, skill, coordination, determination, and the refusal to give up. The captain, first officer, and flight engineer worked together continuously. They used thrust, they monitored speed, they tried to manage altitude, they communicated with air traffic control. They tried to understand what the aircraft would do next. For more than half an hour after the failure, Flight 123 remained airborne. That fact alone is extraordinary. Most aircraft suffering complete hydraulic failure and loss of major tail structure would not be expected to remain under any meaningful control. But the crew kept it flying, not safely, not normally, but flying. Chapter 10. Over the mountains. As Flight 123 moved inland, the terrain below became more dangerous. Japan's landscape west and northwest of Tokyo includes mountains. For an aircraft with normal control, terrain can be avoided by altitude, navigation, and heading. For Flight 123, the mountains became a trap. At one point, the captain warned of terrain ahead. The crew increased thrust to climb. The aircraft responded unpredictably. Sometimes more power helped. Sometimes it caused the nose to rise too far. Sometimes the airplane slowed and risked stalling. Then it would pitch down and accelerate. The crew was trapped between two dangers. Too slow, and the airplane could stall. Too fast, and the aircraft could dive toward terrain. Too much thrust, and the nose might rise uncontrollably. Too little thrust, and the aircraft might descend into the mountains. They tried to lower the landing gear to increase drag and control speed. They later used emergency systems to extend flaps. Each action changed the aircraft's behavior, but nothing restored normal control. By this stage, the flight was no longer about reaching Osaka. It was no longer even clearly about reaching Haneda. It was about surviving the next oscillation. Chapter 11. Passengers writing goodbye. Inside the cabin, passengers began to understand the severity of the situation. Some wrote final notes, messages to wives, to children, to parents. These notes are among the most painful parts of the disaster. They show that many passengers had enough time to think, enough time to understand that the airplane might not survive, enough time to say goodbye. That is one of the reasons Japan Airlines Flight 123 remains so haunting. It was not an instant crash. It was 32 minutes of fear, hope, and waiting. The passengers knew something was wrong. The crew knew the aircraft was barely controllable. Air traffic control knew the flight was in distress. But no one could stop the chain that had begun at the tail of the airplane. In aviation disasters, time can be merciful when it gives crews a chance to solve a problem. But time can also be cruel. On Flight 123, every minute gave the crew another chance, and every minute gave the passengers more time to understand. Chapter 12. The final descent begins. By 6:47 p.m., Tokyo Control asked whether the crew could control the aircraft. The captain's answer was simple. It was uncontrollable. Soon after, terrain became an immediate threat. The captain called out that they were going to hit a mountain. The crew applied maximum thrust. They tried to turn. They tried to raise the nose. They were constantly reacting to an aircraft that was no longer responding in a predictable way. The flight path became erratic. The 747 moved through the mountains northwest of Tokyo. The crew fought to keep it airborne until the final seconds. They extended flaps using emergency systems. They tried to manage speed. They tried to keep the nose from dropping too far. Then the ground proximity warning system began to sound. Sink rate. Pull up, the warning repeated. But pulling up was not something the pilots could simply command anymore. They had been trying to pull up. They had been trying to survive. Chapter 13. It's the end. At 6:56 p.m., the final seconds arrived. The cockpit recording captured desperate commands. Raise the nose, more thrust, hold it, pull up. The ground proximity warning system continued. Then Captain Takahama said words that no pilot ever wants to say. It's the end. Moments later, the aircraft impacted the forested slope of Mount Takamagahara, about 100 kilometers northwest of Tokyo. The Boeing 747 broke apart. Debris scattered across the mountainside. A fire erupted. The crash was catastrophic. Of the 524 people on board, 520 would die. Only 4 passengers survived. It remains the deadliest single aircraft accident in aviation history. Chapter 14. The First Search. After the crash, smoke rose from the mountain. The location was identified relatively quickly. A United States Air Force C-130 reportedly located the crash site and provided coordinates. Japanese rescue units were dispatched. But the terrain was difficult. The crash site was on a steep mountain slope. Fire was present. Night had fallen. Coordination between agencies became confused. A Japanese helicopter reached the area but did not identify survivors and could not land. The decision was made to wait. Rescuers would not reach the crash site until the next morning. That delay became one of the most controversial parts of the entire disaster. Because not everyone died on impact. Some passengers survived the initial crash, and some lived for hours afterward. One of the survivors later described hearing voices and cries after the crash. Doctors later concluded that some passengers who had initially survived died from injuries and exposure while waiting for rescue. This fact adds another layer of tragedy to Flight 123. The disaster did not end when the aircraft hit the mountain. For some, survival depended on rescue arriving in time, and it did not. Chapter 15. The 4 survivors. When rescuers finally reached the wreckage, they found 4 survivors. All were seated in the rear section of the aircraft. One was Yumi Ochiai, a Japan Airlines flight attendant who had been traveling as a passenger. Another was Hiroko Yoshizaki, traveling with her 8-year-old daughter Mikiko. The 4th was 12-year-old Keiko Kawakami, who was found in a tree. They had survived the deadliest single aircraft crash in history. Their survival was extraordinary, but it also confirmed the painful truth that others had lived after impact. Keiko later said that her father had spoken to her after the crash, encouraging her before falling silent. The mountain had not killed everyone instantly. That knowledge would haunt Japan, and it would raise painful questions about rescue coordination, response time, and responsibility. Chapter 16. The investigation begins. Investigators from Japan's Aircraft Accident Investigation Commission began examining the wreckage, the aircraft history, and the flight recorders. The central question was clear. Why did the tail fail? The answer led back 7 years. On June 2nd, 1978, the same aircraft, JA-8119, had suffered a tail strike while landing at Osaka. The rear of the aircraft struck the runway. That event damaged the aft pressure bulkhead. A repair was carried out, but the repair was not completed according to Boeing's approved procedure. The correct repair required a single splice plate with 3 rows of rivets to reinforce the damaged bulkhead. Instead, the repair used 2 separate splice plates. One section had 2 rows of rivets. Another had only 1 row. That difference may sound small, but in aircraft structures, small deviations can become fatal over time. The aft pressure bulkhead is loaded and unloaded every time the aircraft is pressurized and depressurized. Each flight cycle adds stress. With the incorrect repair, the stress was not distributed the way it should have been. Cracks began to grow. Flight after flight, cycle after cycle, year after year. For 7 years, the flawed repair remained hidden. Then, on August 12, 1985, the weakened bulkhead failed. Chapter 17. How one repair destroyed a 747. The failure sequence was brutal. The aft pressure bulkhead ruptured. Pressurized cabin air rushed into the tail section. The sudden pressure load damaged the vertical stabilizer. The tail fin separated. Hydraulic lines running through the rear of the aircraft were severed. All 4 hydraulic systems failed. This is why the crew could not control the aircraft. Not because the engines failed. They did not. Not because the pilots made a simple mistake. They did not. The aircraft had lost the systems that allowed pilot inputs to move the control surfaces. The vertical stabilizer, which normally keeps the aircraft directionally stable, was gone. The hydraulic systems, which normally move the flight controls, were gone. The 747 was left with thrust as the only meaningful control method. The disaster was not caused by one dramatic failure in the sky. It was caused by a hidden structural weakness created years earlier. A repair that should have restored strength instead left the bulkhead vulnerable. The airplane flew thousands of cycles afterward. Every flight looked normal, until the structure finally reached its breaking point. Chapter 18. Responsibility. After the accident, Japan Airlines accepted partial responsibility. The company had not adequately detected the defective repair during later inspections. The president of JAL, Yasumoto Takagi, resigned shortly after the crash. The tragedy also led to deep personal consequences within the airline. The head of maintenance at Haneda died by suicide. The crash forced immediate inspections of Japanese Boeing 747 aircraft. Dozens of issues were reportedly found and corrected. The flight number on the Tokyo to Osaka route was changed from JAL123 to JAL127. The accident became a national trauma. In Japan, the memory of Flight 123 is not only about aviation, it is about families, responsibility, corporate accountability, technical failure, and the painful question of whether more lives could have been saved after the crash. Chapter 19. The crew's fight. One of the most important conclusions from this disaster is that the crew fought until the end. It is easy, after an accident, to look at a flight path and ask why the pilots did not simply fly to an airport. But Flight 123 was not normally flyable. The pilots were not choosing an imperfect route. They were fighting for any control at all. They managed to keep a severely damaged 747 airborne for 32 minutes after the failure. They used differential thrust. They coordinated under extreme stress. They communicated with air traffic control. They tried to avoid terrain. They tried to configure the aircraft. They tried until impact. Their final minutes were not a failure of will. They were a demonstration of how far human skill can go, and where physics finally wins. Chapter 20. Why this story still matters. Flight 123 remains one of the most important accidents in aviation history, not only because of the number of lives lost, but because of what it revealed. It showed that an improper repair can remain hidden for years. It showed that pressurization cycles can slowly turn a small structural weakness into a catastrophic failure. It showed that even redundant hydraulic systems can be lost if their lines are routed through a common vulnerable area. It showed the limits of aircraft control after total hydraulic failure, and it showed that rescue coordination after a crash can determine whether initial survivors live or die. Aviation safety is built on layers: design, maintenance, inspection, procedures, training, emergency response. Flight 123 showed what happens when one damaged layer remains unnoticed until it destroys all the layers above it. Chapter 21. The human memory. Every disaster leaves numbers. 524 on board, 520 dead, 4 survivors, 32 minutes in the air after the failure. But numbers cannot carry the whole weight of this story. The goodbye notes found in the wreckage speak more clearly. They remind us that the passengers were not statistics. They were people who understood, in the final minutes, that they might not return home. The 4 survivors remind us that survival was possible. And the delayed rescue reminds us that the difference between life and death does not always end at impact. The crew's voices remind us of something else. They never stopped trying. Even when the airplane no longer obeyed. Even when the mountains were ahead. Even when the warnings were sounding, they kept fighting. Chapter 22. Final reconstruction. Imagine the aircraft at 24,000 feet, a normal evening flight. Then the explosion. The masks drop. The tail is gone. The hydraulics are gone. In the cockpit, the pilots do not yet know the shape of the damage. They only know the airplane is not responding. Tokyo Control gives vectors. The crew tries to turn. The 747 swings and climbs and dives. The cabin crew prepare passengers. Families hold each other. Some begin writing messages. The aircraft moves inland. The pilots use engine thrust like a crude steering system. The captain calls for maximum thrust. The nose rises. The speed changes. The aircraft falls again. Warnings sound. Pull up, pull up, pull up. But there is no control left to pull up normally. The right wing hits trees. The aircraft impacts the mountain. Then silence. Not complete silence. Because in the wreckage, some people are still alive. And help is still hours away. Final section. Flight 123 was supposed to be a short domestic flight from Tokyo to Osaka. Instead, it became the deadliest single aircraft accident in history. The cause was not weather. It was not terrorism. It was not engine failure. It began with a tail strike in 1978. A damaged pressure bulkhead was repaired incorrectly. For 7 years, the aircraft kept flying. Then, on August 12, 1985, the weakened structure failed. The tail broke apart. All 4 hydraulic systems were lost. The pilots were left with only engine thrust to control a crippled Boeing 747. For 32 minutes, they fought. They kept the aircraft in the air longer than anyone could reasonably expect. But the airplane was too damaged. At 6:56 p.m., Flight 123 struck Mount Takamagahara. Only 4 people survived. The tragedy changed inspections, repair awareness, airline accountability, and the way aviation thinks about hidden structural damage. But its deepest lesson is simpler. In aviation, a mistake does not always reveal itself immediately. Sometimes it waits, flight after flight, year after year, cycle after cycle, until one evening on a crowded holiday flight, the sky gives it back all at once.